Welcome to Naradar Academy. In this video, we are going to discuss about partial differential equations and how to find partial differential equation by eliminating the given arbitrary functions and arbitrary constants. Okay, first let's start with a partial differential equation. See, suppose we have a function z which is dependent on two variables. Z is a function which is dependent on two variables x and y. Then in that case, see, the value of z varies when x varies and also when y varies. Suppose if I want to find what is the rate of change of z with respect to x, okay, at that time I have to keep the other independent variable y as constant, and I have to find dou z by dou x. This is called partial derivative of z with respect to x. That is, keep one of the independent variable as constant and find the derivative of z with respect to x. That is called partial derivative of z with respect to x. And similarly, keep x as constant and find the rate of change of z with respect to y. That is dou z by dou y. This is called what? Partial derivative of z with respect to y. Okay, so the partial derivatives occur when our variable depends on two or more independent variables. This x and y are independent variables. So when you have two or more independent variables, in that case we have partial derivatives. Okay, so there are two, since here we have two independent variables, no, so there are two first order partial derivatives. One is dou z by dou x, another one is dou z by dou y. This is represented by P, and Q is dou z by dou y, and there are three second order derivatives. Okay, R, which is dou square z by dou x square, and T is dou square z by dou y square, and S is dou square z by dou x dou y. So these are standard representations. Okay, so with this introduction, let us go to formation of partial differential equation by eliminating arbitrary constants. So in the following problems, you will be having an expression which contains the variables z, x, y and some arbitrary constants. Okay, what we have to do is, we have to find out the partial differential equation by removing the arbitrary constants. That is, in the resulting equation, you will get only the variables x, y, z and their derivatives only. No a and b terms should be there. Okay, so that is the first section we are going to discuss. So let us see this problem. Z equal to ax plus by plus a square plus b square. Here z is a dependent variable which depends on x and y. Okay, and this a and b are arbitrary constants. So we want to omit, that is eliminate the arbitrary constants. So for that, what I am going to do is differentiate this expression partially with respect to x and then with respect to y. So let's see what happens. So when you differentiate with respect to x, we get dou z by dou x, that is represented by p, isn't it? So p equal to dou z by dou x equal to, look at this expression. Here this is ax, no? So a into differentiation of x with respect to x is 1. So a only. Plus b will become 0. That is because here y is treated as constant when you differentiate with respect to x. So this by will become 0. And obviously this ab's are constant, no? So their differentiation is also 0. So when you differentiate this expression with respect to x, all these terms, no x terms, no? So all these terms will become 0. Only this ax. When you differentiate with respect to x, it will simply become what? A. Right? So this is my p. Next, let me differentiate the same expression with respect to y. So what will I get? Dou z by dou y. That is my q. Okay, equal to, this ax will become 0 because when you differentiate with respect to y, this x is also a constant. So this term will become 0. And by, when you differentiate with respect to y, it will be simply b. And these are constants, no? So their differentiation is also 0. So what I get? P equal to a and q equal to b. Okay, now look at this expression. Instead of this a and b, I can substitute what? P and q. So that I will get an equation without these a's and b's, isn't it? So let me substitute these values in the given equation. So what I get is that equal to, instead of a, p, px plus qy plus p square plus q square. So this is the required partial differential equation. Okay, right. Then next problem. z equal to ax plus 1 minus a into y plus b, right? Okay, the same way we are going to proceed. First differentiate with respect to x. So p dou z by dou x is equal to this ax will become a, right? And these two terms will become 0 because y is also treated as constant when you differentiate with respect to x, and this b is a constant, so obviously it will also become 0. Next, q equal to dou z by dou y. So it's equal to, this will become 0 and this will become 1 minus a, right? So we find both the first order derivatives. Next, see, look at this equation. Here we have two constants, no, a and b, and this b is not associated with any of the variable x and y, isn't it? Here you see a is coming with x and a is coming with y. So we can find the value of this a by differentiating with respect to x and y. But this b value you cannot get because it is not associated with any x or y. So we cannot find out the value. So I cannot substitute these values here. Okay. In the previous problem, what I did, I find the values of a and b in terms of p and q and substitute it there. But here it is not possible. Why? Because this b is coming alone here. It is not associated with any of the variables. So in that case, what should we do? You try to eliminate, okay, you try to eliminate a from the derivatives you find here. Okay, so look at these two expressions. Q equal to 1 minus a, no? So instead of a, what can I write? P. So Q equal to 1 minus P. So from this itself, you are getting one equation, no? So this is the required partial differential equation. Understand? So either you can find out the values of the arbitrary constant and you can substitute in the given equation. Otherwise, instead of substituting the values, you can derive an equation with the derivatives. In any one of the ways you can do. Okay, right. Then next problem, ax plus b is equal to a square x plus y. So differentiate with respect to x and y. So a into z, differentiation of z is dou z by dou x, plus b will become 0, okay, equal to a square plus differentiation of y will become 0 here. So what I get? AP, this is my p, no? So AP equal to a square or simply p equal to a. Next, differentiate with respect to y. So a into dou z by dou y equal to, this term will become 0, this will become 1. So q equal to 1 by a. Okay, again this is also like the second problem. You see I am having two arbitrary constants a and b. A is associated with x and z, but b is not associated with any of the variables. So you cannot find the value of b by differentiation. Okay, so what you should do with the derivatives that we have found here, no, with these two things we have to write an equation by eliminating the constants. See here p equal to a but q equal to 1 by a. So what can I do? Multiply these two equations. What will you get? P into q equal to 1. So this is the partial differential equation for this particular value. Okay, then next one, z equal to x minus a the whole square plus y minus b the whole square. So now differentiate with respect to x. So dou z by dou x is my p. P equal to 2 into x minus a, and similarly differentiate with respect to y. So q equal to 2 into y minus b. So x minus a is p by 2 and y minus b is q by 2. Substitute these two values in the given expression. So what will you get? Z equal to p by 2 the whole square plus q by 2 the whole square. Therefore p square plus q square is equal to 4z. Okay, the next problem, z equal to a into x plus y plus b, right? So here also you are getting this b without associating with any of the variables. So here also what should I do? Differentiate, find the derivatives and eliminate the constant among the derivatives. Okay, so first differentiate with respect to a. What do you get? P equal to a. Okay, and differentiate with respect to y. So q equal to a. So p equal to q. So this is the required equation. Next one, z equal to ax plus by plus ab. So differentiate with respect to x, I get p equal to a. Differentiate with respect to b, I get q equal to b. So substitute the values of a and b in the given equation. So what do I get? Z equal to px plus qy plus pq. Right? Next problem, z equal to ax plus a square y square plus b. So when you differentiate with respect to x, p equal to simply a and q equal to 2a square y. See here also I am having this b which is not associated with any of the variables. So it's not possible to find the value of b. So simply I'm going to eliminate a from these two equations. So instead of a, you put p. So what will you get? Q equal to 2p square y. Okay, that's all. Then next problem. Z equal to x plus a into y plus b. So what is p? Y plus b, because they are in product, no? So keep this as it is. When you differentiate x plus a, it will be 1. So p equal to y plus b, and q equal to, when you differentiate with respect to y, this is kept as a constant, and when you differentiate this, this will become 1. So q equal to x plus a. So substitute the values in the given equation. What will you get? Z equal to p into q, right? Next problem, z equal to ax e power y plus half a square e power 2y plus b. Now differentiate with respect to x. So p equal to a e power y. Okay, the remaining terms, no x are here, so it will become 0 here. Okay, so p equal to a e power y. When you differentiate with respect to y, q equal to, here one e power y term is there, no? So ax into differentiation of e power y is e power y plus half a square into differentiation of e power 2y is 2 e power 2y. So ax e power y plus a square e power 2y. Now for this problem also, b is occurring here without any of the variables. So I have to eliminate the constant from these two derivatives. So let me rewrite this expression. See, this is x into a e power y plus this I can write it as a e power y the whole square. Okay. But what is a e power y? P. So q equal to x into p plus p square. Right. So this is the differential equation required. Okay. Next problem. X minus h the whole square plus y minus k the whole square plus z square equal to lambda square. So here differentiate with respect to x. What will you get? 2 into x minus h plus this term will become 0, no? And when you differentiate z square, you will get 2z into dou z by dou x. Whenever you differentiate z, you have to put dou z by dou x. Okay. So 2z into dou z by dou x, that is p equal to, lambda is a constant, so 0. Okay, here lambda is a fixed constant, only h and k are arbitrary constants. Okay, right. And when you differentiate with respect to y, 2 into y minus k plus 2z into q equal to 0. Okay, so from this equation I am getting x minus h is equal to minus zp. From here y minus k equal to minus zq. So substitute all the values here. This lambda is a fixed constant, so no need to eliminate it. Okay, when you substitute it here, what will you get? Z square into p square plus q square plus 1 equal to lambda square. Okay, right. Then the next section is formation of partial differential equation by eliminating arbitrary function. Okay, in the previous set of problems, arbitrary constants were occurring, so that we have eliminated. Now we will be having arbitrary functions. The procedure is like the previous set only. Okay. Now look at the first problem. X plus y plus z equal to f of x square plus y square plus z square. Okay, right. Now first differentiate with respect to x. So when you differentiate with respect to x, x become 1. 1 plus y becomes 0 and z will become p. That is dou z by dou x, it's p. Equal to, when you differentiate a function f of something, that will be f dash of the value into differentiation of this function. That is called chain rule. Okay, so f of anything means f dash of the value into differentiation of this value. What is differentiation of this? X square differentiation is 2x plus differentiation of y square is 0 plus differentiation of z square is 2z into dou z by dou x. I told you, no, whenever you differentiate z, you should put either dou z by dou x or dou z by dou y accordingly. Okay, right. So 1 plus p equal to 2 into x plus zp into f dash of x square plus y square plus z square. So this is the derivative with respect to what? X. Next, differentiate partially with respect to y. So what will you get? 1 plus q. That is, when you differentiate with respect to y, this will become 0. X will become 0. Okay. X will become 0. So y will become 1. 1 plus q. Why q I am putting here? Because dou z by dou q. Sorry, dou z by dou y. That's q. Equal to f dash of x square plus y square plus z square into, okay, so whenever you differentiate a function, you put its derivative into derivative of this value. So x square differentiation is 0, y square differentiation is 2y plus z square differentiation is 2z into dou z by dou y. So that will be 2z into q. So here what I get, 1 plus q equal to f dash of x square plus y square plus z square into 2 into y plus z cube. Now I find out the first order derivatives. You check whether elimination is possible here or not. What should I eliminate here? The function f. See, look at these two expressions. I am having f dash on both the equations on the right hand side. So simply if I divide these two equations, I will get f dash be removed, isn't it? So divide equation 1 by 2. So 1 plus p by 1 plus q equal to 2 into x plus zp into f dash of x square plus y square plus z square by 2 into y plus zq f dash of x square plus y square plus z square. So both f dash get cancelled. So finally I am getting 1 plus p by 1 plus q equal to x plus zp by y plus zq. Next you cross multiply and simplify the expression to get it in the form whichever you require. Okay, right. Then next problem, y equal to f of x minus at plus capital F. These two are different functions. Okay, one is small f, another one is capital F. So both are different functions. Capital F of x plus at. Here you see y is a function, y is a dependent variable which depends on the value of x and t. So in all the previous problem we have z as the dependent variable which depends on y and x. Here it is different, y is dependent on x and t. Okay, now let us find the derivative, first order derivative. So here I am not going to use p and q. Usually p and q are used for dou z by dou x and dou z by dou y only. So I am going to write only dou y by dou x and dou y by dou t only. So what is dou y by dou x? F, when you differentiate f, it will be f dash of x minus at into differentiation of this. Differentiation of this would be what? 1. So I didn't write it here. Plus this one is capital F dash of x plus at into what? Differentiation of this. This is 1. Okay, this is dou y by dou x. Next to dou y by dou t equal to f dash of x minus at into differentiation of this. So x will become 0. This minus at will become what? Minus a. Okay, plus f dash of x plus at into a. Right? So you take a outside, it will be minus f dash of x minus at plus f dash of x plus at. Now I find out the first order derivatives. You check whether elimination is possible here or not. It's not possible, isn't it? Because here both are first order derivatives which occur in positive sign, but here one is positive, another one is negative. So we cannot remove them. If you are having like this, you have to differentiate. You have to find the second order derivatives also. Okay. So let me find the second order derivatives. So dou square y by dou x square. So differentiate this with respect to x again. So f dash will become f double dash of x minus at into 1, and this f dash will become f double dash of x plus at into 1. Okay, and this expression you differentiate with respect to t again. So a into minus f dash will become minus f double dash of x minus at into differentiation of this one with respect to t will give you minus a. Plus again this expression will become, this one will become f double dash of x plus at into a. So one more a is common, no? You take that a outside. So it will be a square into f double dash of x minus at plus, minus into minus will become plus here, plus f double dash of x plus at. Now I have 4 derivatives. With these four, either you can any of the 2 or all the 4 or 3. Okay, and you have to eliminate the function. Now simply you see these two expressions, both are containing the same second order derivative, no? So with these two only I can eliminate the what? Eliminate the function. So dou square y by dou t square equal to a square into, instead of this bracketed expression I can simply write dou square y by dou x square. Okay, so this is the required partial differential equation. The next problem, z equal to f of x square minus y square. So find p, that is dou z by dou x is f dash of x square minus y square into differentiation of this function is 2x. Okay, and q, that is dou z by dou y equal to f dash of x square minus y square into minus 2y. Okay, now you see, yes, by dividing these two equations I can get this f be eliminated. So p by q equal to minus x by y. So what I get? Py plus qx is equal to 0. Right. Then next problem, z equal to f of y by x. Same type of problem only. So what is p? Differentiation with respect to x. So P equal to f dash of y by x into. So differentiation of f is f dash into differentiation of this y by x will be what? Minus y by x square, because differentiation of 1 by x is minus 1 by x square. Okay, and q, differentiation with respect to y, equal to f dash of y by x into 1 by x. Okay, now look at these two things. Yes, we can remove the function. So divide p by q. So what I get? Minus y by x square by 1 by x. So it will be simply minus y by x. So the equation is px plus qy equal to 0. Right? Then next problem, z equal to x power n into f of y by x. So what is p? Here you see this is a function of, this is x and this is also function of x. So here you have to apply product rule for differentiation. So x power n into differentiation of f of y by x is f dash of y by x into minus y by x square plus f of y by x you keep as it is, differentiate x power n. Differentiation of x power n is what? N x power n minus 1. Okay, right. Now p equal to, let me bring this minus y by x square in the front. So minus x power n y by x square into f dash of y by x plus n x power n minus 1. See, here itself I want to remove this f because z is given in terms of f, no? So here itself I can remove. Otherwise I have to bring and I have to differentiate again and again. Okay, so instead of this f of y by x, I can substitute what? Z by x power n. So or here I am having x power n minus 1, no, multiply and divide by x. So it will be what? X power n by x. Okay, right? So x power n can be, x power n into f of y by x can be written as z. So n by x into z. This is my p. Next q, differentiate with respect to y. So here only this is the term containing y. So no need to apply product rule. You keep this x power n as it is. So this will be f dash of y by x into 1 by x. So what I get? X power n minus 1 into f dash of y by x. From this I can get f dash of y by x equal to q by x power n minus 1. Okay, why I am writing like this? Because this expression I am getting f dash, no. So instead of this f dash, let me substitute this value. So I get p equal to minus x power n minus 2 y q by x power n minus 1 plus n z by x. Okay, right. So it will be equal to minus y by x into q. So these two things get cancelled and I get only x in the denominator plus nz by x. So p equal to minus yq plus nz by x, or xp plus yq equal to nz. Okay, right. Then next problem. Lx plus my plus nz equal to phi of x square plus y square plus z square. This problem is also eliminating the arbitrary function phi. Okay, right. So you don't bother about this lmn. So differentiate with respect to x. So what will you get? L plus this my will become 0. N into differentiation of z is p equal to differentiation of phi is phi dash of x square plus y square plus z square into differentiation of this term. X square will be 2x plus y square will be 0. Z square will be what? 2z into p, and differentiate with respect to y. So Lx will become 0. M plus n into dou z by dou y is q. M plus nq equal to phi dash of x square plus y square plus z square into 2y plus 2z into q. Okay. So L plus np equal to 2 into x plus zp into phi dash, and m plus nq equal to 2 into y plus zq into phi dash. So just by dividing these two equations, this phi dash get eliminated and I am having this equation. So you can simplify till whichever form is required. Okay, right. Then one more problem. Z equal to a capital F, small f of x plus iy plus capital F of x minus iy. So similar type of problem we have already discussed. So let me first find p and q. So p is dou z by dou x. So differentiate with respect to x. It will be f dash of x plus iy into 1 plus capital F dash of x minus iy into 1. And q equal to f dash of x plus iy into I plus capital F dash of x minus iy into minus I. So you take this I outside, it will be f dash, small f dash minus capital F dash. So see, it's not possible to eliminate the function. So let me find second order derivative also. So differentiate this expression again with respect to x. So it will be r, isn't it? So f double dash of x plus iy into 1 plus capital F double dash of x minus iy into 1. And differentiate this again with respect to y. So it will be t. Second order derivative with respect to y is t. T equal to I into f double dash of x plus iy into I minus capital F double dash of x minus iy into minus I. Again, one more I is common, no, that I take outside, it will be I square into f double dash of x plus iy plus capital F double dash of x minus iy. But what is this I square? I square is minus 1. But look at this expression, small f double dash plus capital F double dash. Here it is r, no, so simply put r. So t plus r equal to 0 is the required differential equation. Okay, right. Then in the last set of problems, we have obtained the partial differential equation by eliminating the arbitrary function. So in all these problems, you were having like this, that is z equal to some function. But I have one more special type of function, phi of uv equal to 0. So if you have problems of this type, if you are asked to find the partial differential equation by eliminating phi from this type of, phi is a function of u and v, where u is a function of xyz and v is a function of xyz. In that case, the formula is capital P into small p plus capital Q into small q equal to R, where the small p and small q are dou z by dou x and dou z by dou y, and capital P, Q, R are having these values. Capital P is Jacobian of Jacobian of uv with respect to yz, and capital Q is Jacobian of uv with respect to zx, and capital R is Jacobian of uv with respect to xy. Okay, and they are given by these determinants. See, what is the Jacobian of uv with respect to yz? Dou u by dou y. First row, dou u by dou y, dou u by dou z. Second row, dou v by dou y, dou v by dou z. And Q is Jacobian of uv with respect to zx. So first row will be what? Dou u by dou z, dou u by dou x. Second row will be dou v by dou z, dou v by dou x. And capital R is Jacobian of uv with respect to xy. So first row will be dou u by dou x, dou u by dou y, and second row will be dou v by dou x, dou v by dou y. So from the given function, you find out the first order partial derivative for this u and v, and substitute in this formula, find capital P, Q, R and write it in this form. That will give you the required PDE. Okay, we will see two examples for this type. So find the partial differential equation by eliminating arbitrary function. Phi of xyz plus x square plus y square plus z square equal to 0. See, this problem is something different from all the previous problems, isn't it? So the first function is taken to be u and the second one is taken to be v. Now from u we have to find what is dou u by dou x, dou u by dou y, dou u by dou z, and similarly for v. See, u equal to x plus y plus z. So dou u by dou x equal to 1 and dou u by dou y equal to 1 and dou u by dou z is equal to 1. See, here you should treat all of them as independent variables for these type of problems. Okay. So, and similarly for v, dou v by dou x is 2x, dou v by dou y is 2y, dou v by dou z is minus 2z. Okay, now what is P? Jacobian of uv with respect to yz. So first row will be dou u by dou y, dou u by dou z. Second row will be dou v by dou y, dou v by dou z. So it's equal to what? Minus 2z minus 2y equal to minus 2 into y plus z. And Q equal to Jacobian of uv with respect to zx. So dou u by dou z, dou u by dou x, dou v by dou z, dou v by dou x. So it's equal to what? 2x minus of minus 2z, that is 2x plus 2z equal to 2 into x plus z. And R is Jacobian of uv with respect to xy. So dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So it's what? 2y minus 2x. So 2 into y minus x. So what is the differential equation? PP plus QQ equal to R, where this small p is dou z by dou x and small q is dou z by dou y. Now you substitute the values for capital P, Q and R. So the resulting equation is this: minus y plus z into p plus x plus z into q equal to y minus x. Then one more problem of this same type. That is, by eliminating the arbitrary function phi, we have to find the differential equation. Phi of x square plus y square plus z square is z square minus 2xy equal to 0. Let us take the first function to be u, x square plus y square plus z square, and v equal to z square minus xy. So dou u by dou x will be 2x, dou u by dou y is 2y, and dou u by dou z is 2z. Dou v by dou x is minus 2y, and dou v by dou y is minus 2x, and dou v by dou z is 2z. So what is P? Jacobian of uv with respect to yz. So dou u by dou y, dou u by dou y, dou u by dou z. This is dou v by dou y, dou v by dou z. So it is what? 4yz plus 4xz. And Q is Jacobian of uv with respect to zx. So dou u by dou z, dou u by dou x, dou v by dou z, dou v by dou x. So minus 4zy minus 4zx. So it will be minus 4z into x plus y. And r is Jacobian of uv with respect to xy. So dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So minus 4x square plus 4y square equal to 4 into y square minus x square. So finally the equation is pp plus qq equal to r. Substitute the values of capital P, Q and R. So this is the resulting equation. Zp minus Zq equal to y minus x. That's all. Thank you.